Good morning, students. Hope you are fine. After the chapter statistics, I think there was a long gap. I could not upload any videos because of some examination correction work. So today I am going to start a new chapter that is in geometry. My dear children, you know very well that class 10th mathematics has very less chapters of geometry. It is not like class 9th mathematics. Last year you studied around 50% of your curriculum in the geometry itself. But for the class 10th we have only 3 chapters under geometry. One is similar triangles, one is circles, and one is constructions. In the class 9, you have studied about congruent triangles, and you know very well what are congruent triangles. We can say like this, that triangles which are same in shape and same in size. Same in shape and same in size, we call them as a congruent. For example, we can see the 2 identical windows, 2 identical coins. When they keep on one another, they should coincide in all respects. Then we can call those 2 triangles as, those 2 figures as congruent figures. You take 2 circles of the same radius, they are congruent. 2 line segments of the same measurement, congruent. 2 equilateral triangles with the same measurement, they are congruent. But in the class 10, we are learning a different type of triangle which we call them as a similar figures or similar triangles. We will talk about similar triangles. What are the similar triangles and how they differ from congruent? My dear children, we can say like this, 2 figures. I'm coming to the similar triangles later, but we'll take some different examples first. 2 figures are said to be similar if they have the same shape. Only that much. They have the same shape, but size need not to be same. See, if shape and size both are same, then we can call them as a congruent figures. But here we say they are the same in shape, different in size. Different in size. We can call them as similar figures. I will show you some pictures. Look at this. Look at this. Can you call them as congruent? Definitely. Definitely. Because these are the 3 circles. They are not identical. Their radius is not same. Had their radius is same, you would have called those circles as congruent circles. But now they are in the same shape, but different in radius. I can say different in size. We can call them as similar circles. Similar circles. I can say like this. 2 circles are said to be, any 2 circles can be said as similar circles. Any 2 circles. Whatever may be the radius, we can call them as similar circles. Look at this. These are the squares. All sides are equal. All sides are equal. But they are not congruent squares. They are not congruent. But I can say they are similar. They are similar. Means same in shape, different in size. Same in shape, different in size. We can call them as any 2 squares. Any 2 squares. This may be of any measurement. This can be of any measurement. Any 2 squares, we can call them as a similar squares or similar figures, I can say. Look at this. Look at this. These are 2 equilateral triangles. 2 equilateral triangles. The first equilateral triangle is having 7 cm each side. The second equilateral triangle is having 5 cm each side. Definitely they are not congruent, but they can be called as similar figures. Ultimately, what have we learned? Two figures are said to be similar if they have the same shape but different in size. I can say two figures are said to be similar if they have the same shape. But this is not a definition. This is not a definition. How we can define two similar figures? For that, I will show you one more figure. Look at this. Look at this figure. These are the two polygons. These are the two polygons. They are having the same shape. They are having the same shape, but different in size. Different in size. You can see those two figures. Their corresponding angles are equal. See, this is 90, and here 1 minute. See, this is 100 degree. This is 100 degree. This is also 100 degree. This is 80 degree. This is also 80 degree. This is 125 degree. This is also 125 degree. Their corresponding angles are equal, whereas the sides are not equal, but the sides are proportional. This is a very, very important word, proportional. See, what we used to say in the congruency? They have the equal length. The side must be same. But here sides are not same. The sides must be proportional. Sides must be proportional. So how we can define? How we can define? Right like this. Two figures are said to be similar. Said to be similar. Two figures are said to be similar if there are two conditions. Two figures can be said to be similar under when these two conditions are satisfied. Which are the two conditions? The first one. Corresponding angles are equal. Angles are equal. And the second one, the corresponding sides are proportional. Corresponding sides are proportional. So what is this proportional? I will give you an example. Look at this. Look at this figure. I can draw one rectangle. Okay. Okay, student, this is one rectangle. I will call it as ABCD. This is 12 centimeter and this is 7 centimeter. I will draw another rectangle. I will draw another rectangle. Okay. Look at this figure, you get idea what do you mean by similar. Okay, A, B, C, D. I will call it as P, Q, R, S. This is 6 centimeter and this is 3.5 centimeter. These are the two rectangles. See, if I want to say those two triangles are similar, I have two different conditions. First one, the corresponding angles are equal. 90, 90, 90, 90, 90, 90, 90, 90. Corresponding angles are equal. See, all are 90 here. Corresponding angles are equal, and they say the corresponding proportional. My dear children, what do you mean by proportional? When you divide the two corresponding sides, whatever the answer you are getting, the same answer you should get when you divide the other corresponding sides also. Meaning, see, I will divide 12 by 6. Answer is 2. 7.5 by 3.5. Answer is 2. I can say the two triangles are, or the two figures are, two rectangles are similar figures. The condition is the corresponding angles are equal and the corresponding sides are proportional. You can see this figure once again. I can call these two figures are definitely a similar figures. You can see properly. All the corresponding angles are equal and see the corresponding sides are proportional. Look at this. The corresponding sides are proportional. When these two conditions are satisfied, then only you can call the two figures as similar figures. Similar? Let me draw one more figure. Let me draw one more figure. Let me draw one more figure. Okay, students, look at this. Let me call this as ABCD. This I will call it as PQRS. Let me call this as 60 degree here, 60 degree here, 120 degree here, 120 degree here, again 120 here, 60 here, 120 here and 60. What I can say? The corresponding angles are equal. I will write here 5 centimeter and 7 centimeter. Now can I call these two figures as similar figures? My dear children, definitely they are not similar figures. Because when the figures are similar, they should satisfy two conditions. What? The first one, the corresponding angles are equal. Yes, the corresponding angles are equal. No doubt, it's right. But the corresponding sides must be proportional. See, when you divide 10 divided by 5, the corresponding sides are getting answer as 2. But when you divide 12 by 7, your answer is not 2. Had it been 6, had it been 6, 12 by 6 answer is also 2. Then you would have called those two figures as similar figures. But now the sides are not proportional because on dividing we are getting here 2. Here when you divide the answer is not 2. That means one condition is satisfied, the second one is not satisfied. I can say two figures, all I can say ABCD and PQRS are not similar. Because corresponding sides are not proportional. What do you mean by proportional? See, 10 by 5 is not equals to 12 by 7. This is the meaning of proportional. Whatever the answer you are getting on dividing this, that must be equal to the whatever the answer you are getting on dividing these two. When corresponding sides are divided, their answers must be equal. Then only we can say the corresponding sides are proportional. Okay, students. Now, after discussing about similar circles, similar triangles, similar what you can say squares, similar polygons, we will discuss about the similar triangles. No doubt the definition is same. Definition is same. What I can say? Two triangles are said to be similar if the corresponding angles are equal and the corresponding sides are proportional. Corresponding sides are when these two conditions are satisfied, then we can say the triangles are similar. But my dear children, this rule is slightly modified, simplified in the case of a similar triangles. See, to make or to get the two triangles are similar, both conditions need not to be satisfied. Keep this point in your mind. See, when I was discussing about the similar polygons, it may be pentagon, it may be hexagon, it may be octagon, whatever it may be. When I was talking about the polygons, I have told you these two conditions must be satisfied. These two, I have shown in the case of a rectangle also. I have said the rectangles are not similar because the sides are not proportional. Even though the angles are equal, the sides are not proportional, so definitely they are not similar. But in the case of a triangle only, it is not necessary that both conditions must be satisfied. If one condition is satisfied, automatically second will be satisfied. What am I telling? Either the angles must be equal, corresponding angles must be equal, or the corresponding sides are proportional. With this, definitely you can say the triangles are similar. But when you write the definitions, you should write both. The corresponding angles are equal and the corresponding sides are proportional. Now I have two figures on the board, two triangles on the board. See here, this is 13 centimeter, this is 6.5 centimeter. When you multiply 6.5, 2s are 13, 6 2s are 12, 5.5 2s are 11. I can say the corresponding sides are proportional, which is corresponds to what? I am writing AB is corresponding to what? AB is corresponding to PQ. BC is corresponding to BC is corresponding to QR. Or I can write like this. Okay, and I can write AC is corresponding to PR. I can write like this now. AB divided by PQ is equal to BC divided by QR. BC divided by QR is equal to AC divided by PR. AC divided by PR. If I write like this, it shows that the corresponding sides are equal. The corresponding sides are the corresponding sides are proportional. The corresponding sides are proportional. See, every when you divide, the answer is 2. 13 by 6.5, answer is 2. 12 by 6, answer is 2. 11 by 5.5, answer is 2. So, I don't know anything about the angles here, but I know both the sides are proportional. Definitely I can say the triangles are similar. The triangles are similar. Coming to the second figure. See, angle A is equal to angle X, angle B is equal to angle Y, angle C is equal to angle Z. I can say the corresponding angles are equal. I don't know anything about the sides. Even then I can say triangle ABC is similar. See, this is the symbol we are using for similarity. You may be knowing this was the sign for the congruency. We are using the similarity. Triangle ABC is similar to triangle XYZ. This much you should remember in the case of Two triangles are said to be similar if the corresponding angles are equal and the corresponding sides are proportional. But the inner meaning is out of those two, if any one of the conditions is satisfied, definitely the second also will be satisfied. Note all these pictures. So far, what we have learned, two triangles are said to be similar if the corresponding angles are equal and the corresponding sides are proportional. Before we proceed further, let us go for a small activity. Let us go for a small activity. What I will do, I will draw one angle. I will draw one angle. Any angle. I will call it as, I have drawn one angle. Let me call the angle as PAI. Okay. Now, on this arm AB, what I will do? I will draw some arcs, equal arcs I will draw. Okay. Say 1, 2, 3, 4. Say I have drawn 5 arcs. I have drawn 5 equal arcs. I will call them as A1, A2, A3, A4, and A. Then what I will do, I will join. Okay, I will join P and A5. P and A5 I will join. Now what I will do, from this third arm or from the second arm, anywhere, I will draw a line parallel. You can do this activity. You can draw a parallel to this. Exact parallel line has to be drawn. Exact. I will show you the method of drawing the parallel nature. Okay. I will draw the parallel. Now there are two parts. This is one length. This is the second. Measure. If I measure, it will be. It is 9 centimeter and this is 6 centimeter. If I measure this is 9 centimeter and this is 6 centimeter. And if I measure this, this is 8 centimeter. This is 8 centimeter. Sorry. This is 7.5 centimeter and this is 5 centimeter. This is 7.5 centimeter and this is 5 centimeter. So what we conclude from this activity is, if I divide these two parts, see, if I divide these two parts, is 9 by 6. 9 by 6, answer is 3 2s are 3 3s are, answer is 3 by 2. And if you divide these two, 7.5 divided by 5, nothing but 75 divided by 50. 75 divided by 50, 25 2s are, 25 3s are, this is also 3 by 2. That means I can say the sides are proportional. The sides are proportional when the lines are parallel. When the lines are parallel, the sides are proportional. This is a very, very important result which is called as the Thale's theorem or the basic proportionality theorem. What the theorem says, how the theorem can be proved, that we will discuss later. But I can say this is one of the most important theorem in the similar triangles. What it says? When the lines are parallel, the sides must be proportional. Sides must be proportional. Okay, so let us go for the theorem which is called as basic proportionality theorem. Basic Proportionality Theorem. In short, we call it as BPT, Basic Proportionality Theorem, which is also called as Thale's Theorem. Thale's Theorem. This is given by the Greek mathematician Thale. So it is named after him. This is called as the Thale's Theorem. Okay, what the theorem says? What the theorem says? Let me write the statement first. In any triangle, a line drawn parallel to one side of a triangle, intersects other two sides at distinct points, divides the two sides in the same ratio, Many of you might not understood what is the meaning of this. I will explain you. Listen very carefully. And I have told you one of the most important theorem from the examination point of view, as well as for the problem solving part is concerned. This is the most important theorem. Okay, let us discuss about this. What does it say? In any triangle, you may be having a lot of doubts. So listen very carefully. I will teach you very slowly. Okay? But your attention is very much required. This is any triangle. I am not saying that it is isosceles, equilateral, scalene, equitriangle, nothing. It can be any triangle. I will call that triangle as triangle PQR. See, in any triangle, a line drawn parallel to one side of triangle. I have to draw a parallel line to any one side. See, for this, I can draw a parallel here. I can draw a parallel here. Anywhere I can draw a parallel to this. Or I can draw a parallel to this. I can draw here parallel to this. I can draw a parallel to here. Anywhere. Or for this side, I can draw a parallel here. Or here. Parallel to any one side of a triangle. I will draw a parallel line like this. This is a parallel line. Parallel to what? Parallel to QR. I will call this as MN. This is the parallel line. See, a line drawn parallel to one side of triangle. A line drawn parallel to one side of the, this is the first side. A line drawn parallel to one side of the triangle. Triangle intersects the other two sides at distinct points. This line intersects the other two sides at distinct points, different points. Divides the two sides. Then this line divides the two sides in the same ratio. Nothing is equal, my dear children. Nothing is equal. This is not equal to this. 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 Nothing is equal. But they say this line divides the two sides in the same ratio. That means PM and MQ on dividing these two, what answer you are going to get? The same answer you are going to get on dividing these. Don't get confused. Nothing will be equal. Only they are proportional. That means PM divided by MQ is equals to PN divided by M. Say for example, this is 4 centimeter and this is 8 centimeter. This is 5 centimeter, this is 10 centimeter. See, nothing is equal, but they are proportional. How? 4 divided by 8, answer is 1 by 2. 5 divided by 10, answer is 1 by 2. That is called as a proportional when it is possible. Only when a line is drawn parallel to one side of the triangle. Ultimately, what the Thale's theorem says, for any triangle, if a line is drawn parallel to one side, which intersects the other two sides at two distinct points, then these two sides are divided by this line in the same ratio. Ratios are equal to each other. No sides are equal, but the sides are proportional. This is what we are going to prove it. Okay. Let me write what are the given things. To prove a theorem means what are the necessary things you learned in the class 9. Given, to prove, construction and the proof. These are different. Figure, then you write the given, to prove, construction and the proof. Okay, what is given? PQR is a triangle. PQR is a triangle in which MN is parallel to QR. MN is parallel to QR. This is given for you. What is to be proved? To prove it is PM divided by MQ is equals to PN divided by NR. PM divided by MQ is equals to PN divided by NR. This is to be proved. Okay? You first know all these things. So, given, to prove. The next step is the construction. What are the construction needed? I will draw it at once. Okay? What are the constructions needed? See. The constructions are, this is a trapezium. When these two are parallel lines, I can call MNRQ is a trapezium. I will join both the diagonals of the trapezium. Okay? This is the first diagonal and this is the second diagonal. Okay. Then from this point M, I will draw one perpendicular. I will draw one perpendicular to this is a perpendicular. Angle is 90. From M also a perpendicular is drawn. From here also a perpendicular is drawn. I will call those two points as I will call them as X and Y. X and Y. This much is the construction. Okay? So there is a chance to make it confusing. So first I will write, later I will rub and I will explain once. Okay, the construction is draw NX perpendicular to PM, MY perpendicular to PN, join MR and NQ. second part I have removed. Again later from this point I will draw this diagonal also, I will draw one perpendicular also later. Okay. Now how I will start? Now the proof will start. How to prove it? Okay. Which triangle I will show you? Just focus on that triangle. Okay, students. PMN is the first triangle. What I am going to choose. PMN is the triangle. My dear children, can I say for this triangle, this is the base and this is the height? This is the base and this is the height for triangle PMN. I will write area of triangle PMN is equals to, you know, the formula for area of the triangle is half into base into height. Half into base into height. That means half into base into height. It is half into PM into what? PM into XN. Yes. N. Half into, I'll put a dot for that, okay? Into means dot, because into and x should not be confusion for the PM into xn. Next I will go to the second triangle. Just first I will take the triangle this, the second I will take the triangle this triangle. MNQ. I will write area of triangle MNQ. Look at this, students. For this triangle, see, I have taken the first triangle PMN. The first here I have taken the triangle. This is the base and this is the height. Just below, I have taken the second triangle MNQ. For this, what is the base? M2 is the base, and where is the height? Some students are thinking that, sir, this is the height. No, my dear children, that is not the height, because it is not given that this is 90 degree here. But which is the height? Can I say this is only the height for this triangle also? You may say, no sir, it is not possible, क्योंकि ट्रायंगल से बाहर है, वो कैसा हाइट बन सकता है? But my dear children, this is the height for this triangle also. एक ट्रायंगल के लिए XL is the height. ऐसा क्यों? देखो, आप थोड़ा याद करो, क्लास 8 में आप सीख चुके हैं, एक कोई भी एक्यूटेंगल ट्रायंगल के लिए the perpendicular always lies inside the triangle. परपेंडिकुलर लाइज इनसाइड. एक एक्यूटेंगल ट्रायंगल में हमेशा परपेंडिकुलर ट्रायंगल के अंदर ही हो, वेरेज एक ऑब्टूज एंगल ट्रायंगल के लिए हमेशा परपेंडिकुलर ट्रायंगल से बाहर होगा. ये आप सीख चुके हैं, ठीक है. अब आइए देखो, अगर एक ट्रायंगल के इसका परपेंडिकुलर ट्रायंगल का अंदर है, मतलब एक एक्यूटेंगल ट्रायंगल होना है. दिस इज डेफिनेटली एक्यूटेंगल. जब ए एक्यूटेंगल है तो डेफिनेटली ए एंगल कैसा होना चाहिए? ऑब्टूज होना चाहिए, क्योंकि सम ऑफ दीस टू इज इक्वल्स टू 180. ये दोनों का सम 180 है. जब ए एक्यूट होगा डेफिनेटली ए ऑब्टूज एंगल होना ही है. चाहे तो आपको मैं एक फिगर यहां बनाकर दिखाता हूं ताकि आपको समझ में आए. देखो, come on, you see here I have drawn one acute angle triangle. देखो, इसका परपेंडिकुलर अंदर है, मतलब ए एंगल भी एक्यूट है, ए एंगल भी एक्यूट है, ए एंगल एक्यूट है, एक्यूट एंगल है. इसके जस्ट बगल में अगर मैं एक दूसरा ट्रायंगल बनाता हूं ऐसा, ए जब एक्यूट होगा डेफिनेटली दिस इज ए ऑब्टूज एंगल, क्योंकि ये दोनों का सम हमेशा 180 होना चाहिए. एंड व्हेन दिस इज एन ऑब्टूज एंगल ट्रायंगल, इसका परपेंडिकुलर ट्रायंगल से बाहर होना ही है. ये तो प्रॉपर्टी. इन एक्यूट एंगल ट्रायंगल परपेंडिकुलर इनसाइड द ट्रायंगल, व्हेreas इन ऑब्टूज एंगल ट्रायंगल परपेंडिकुलर आउटसाइड. यही बात यहां अप्लाई करूंगा, मतलब ए ट्रायंगल एक ऑब्टूज एंगल ट्रायंगल है, इसका परपेंडिकुलर ट्रायंगल से बाहर है, मतलब nx is the common perpendicular, common altitude, common height for both the triangles NPM. इसका भी हाइट है, NMQ इसका भी हाइट यही है. Yes, that I am going to write here. Okay, area of the MMQ. Come on, half into base मतलब MQ into height तो कॉमन ही करोगे and I can write it as NX or XM. Come on, अब मैं क्या करूंगा, दोनों को डिवाइड कर दो. Your half gets cancelled, XN gets cancelled, and can write therefore area of angle PMN divided by area of angle MNQ is equals to PM divided by MQ. Call this as equation number 1. देखो क्वेश्चन, PM by MQ जो भी हमको प्रूव करना था एक ऑलरेडी हमको मिल चुका है, ठीक है, इसको भी प्रूव करना है. कम ऑन, यहां तक आ गए. अब मेरा ए कंस्ट्रक्शन का काम खत्म. अब मैं क्या करूंगा, यही जो मैंने प्रूव किया है अब मैं दोबारा यहां से स्टार्ट करूंगा. चलो ए डायगोनल को जोड़ दो. यस, एंड यहां से आप सॉरी अभी ऑलरेडी हो चुका है, ये हो चुका है, इसको जोड़ना है. तो जॉइन दिस. अब मैं यमा को जोड़ दूंगा. आई विल जॉइन दिस एंड फ्रॉम देयर आई विल ड्रॉ वन परपेंडिकुलर. स्मॉल यस, देखो जो मैंने किया है उसको दोबारा वैसा ही रिपीट करेंगे. कम ऑन, एरिया ऑफ ट्रायंगल. अब पहला वाला ट्रायंगल कौन सा है, वही पीएमए. यहां पे मैंने पीएमए लिया था, ये भी पीएमए है, लेकिन उसका बेस अलग हो गया. पहले यहां बेस था और ए हाइट था इन द फर्स्ट केस में. अब ए बेस हो गया और ए हाइट हो गया. कम ऑन, टेल मी area of triangle PMN is equals to half into base into height, half into base यानी PM into height यानी MY. वही ट्रायंगल लेकिन बेस और हाइट अलग हो गया. पहले कैसे PM बेस नेक्स्ट हाइट, अब PM बेस और MY हाइट. कम ऑन, अब इसके नीचे वाला ट्रायंगल है कौन सा ट्रायंगल, एरिया ऑफ ट्रायंगल. कम ऑन, पहले मेरा यहां था कंस्ट्रक्शन, ए ट्रायंगल लिया था मैंने, लेकिन अब मैं ये ट्रायंगल ले रहा हूं. कम ऑन, सेकंड ट्रायंगल NMR. एरिया ऑफ ट्रायंगल NMR और MNR वन से NR is equals to half into base तो यही है NR, half into NR into height. एक ट्रायंगल के लिए भी हाइट यही होगा into MY. अब मैं दोनों को डिवाइड कर देता हूं. डिवाइड बोथ, हाफ gets cancelled, MY gets cancelled. जो प्रॉपर्टी बचेगा उसको मैं लिख लूंगा. एरिया ऑफ ट्रायंगल व्हाट, PMN divided by area of triangle MNR is equals to what, PN by NR. Call it as equation number 2. ध्यान रखिए. अब दोनों में इक्वेशंस का RHS को देखिए. लेट्स सी द RHS. PM by MQ, PN by NR, PM by MQ, PN by NR. जो मुझे प्रूव करना if I am cancelling the LHS, I can write Pm by M2 is equals to Pm by Nr. But my dear children, I can't cancel LHS of both. क्या प्रॉब्लम है? प्रॉब्लम क्या है? देखो, see the numerator, area of PMN, area of PMN, area of PMN, numerator सेम है, लेकिन डिनोमिनेटर देखो, MNQ है, MNR है, डिनोमिनेटर दोनों अलग है। अब मैं क्या करूँगा? अब आपका जो कंस्ट्रक्शन ओरिजिनल था उसको मैं एज इट इज कर दूँ। दोनों ट्रायंगल्स हो गए, अब मेरा कंस्ट्रक्शन वापस आ गया। यस, अब देख लो डिनोमिनेटर अलग अलग है। एक डिनोमिनेटर क्या है? MNQ, MNQ, ये वाला ट्रायंगल है MNQ, और दूसरा वाला MNR है, MNR। दोनों डिनोमिनेटर अलग अलग है। अगर ये दोनों अगर सेम होते तो LHS को कैंसिल कर देता और ध्यान में रखते हैं Pm by M2 is equal to Pn by Nr, that would have been the end of the problem. Now, somehow we have to prove that ये दोनों areas आपस में equal है। कौन सा? This denominator and this denominator. So that I can cancel these two. How to prove these two areas are equal? Which one? MNQ and MNR. MNQ और MNR का area आपस में equal है। Why? You have learned in the class 9th. What you learned? The two triangles which are on the same base and between the same parallels are equal in area. This is what you have learned in the class 9. देखो, ये दोनों triangles, these two triangles are lying on the same base. And then base पर दोनों हैं, these two are lying on the same base, and they are between the same parallels. They are between the same parallels. Then the areas must be equal. Yes, I can write further. Area of triangle MNQ is equals to area of triangle MNR. क्यों? Why? Because triangles on the same base, triangles on the same base and between same parallels and between same parallels are equal in area, yes। दोनों इसको मैं लिखूंगा इक्वेशन नंबर 3, इक्वेशन नंबर 3 देखो, इक्वेशन 1, इक्वेशन 2, इक्वेशन, तीनों इक्वेशन को देखो। You can see, you have to see all the 3 equations. MNQ, MNR दोनों इक्वल, मतलब MNQ के बदले में MNR अगर लिखता हूं तो ये दोनों को मैं कैंसिल कर सकता हूं। LHS of both the equations are getting cancelled. I can write here from equation 1, 2 and 3, तीनों इक्वेशन को अगर आप साथ देखते हो, by taking all the 3 equations together, क्या कर सकता हूं? I can cancel LHS of both. मैं पहले बोला था कैंसिल नहीं कर सकता, अब मैं दोनों कैंसिल कर सकता हूं। क्यों? इधर क्या प्रॉब्लम था? MNQ MNR अलग अलग थे, लेकिन मैंने प्रूव कर दिया MNQ MNR का एरिया इक्वल है, मतलब दोनों इक्वेशन का LHS कैंसिल। And you can write from 1, 2 and 3, I can write Pm by MQ is equals to Pn by Nr. That is the end of the theorem. Whatever you want to do, Pm by MQ is equals to Pn by Nr. That is the end of the theorem. Very, very important theorem, my children. Very, very important theorem. And most important from the examination point of view, many times in the board examinations, theorem is asked. So, practice one. And before I wind up today's session, we'll see once again what exactly the theorem says. Very simple. Okay, I will rub this and let me draw some figures and I will explain you what is the meaning of this theorem. Come on. figures are written. Okay. Okay, students, I am having three different figures. For your practice, I will call it as A, B, C, P, Q. All of it. Listen very carefully. इसमें मैं क्या दे रहा हूँ? मैं क्या दे रहा हूँ? I am giving you PQ is parallel to AC. M के देना ही है. अगर बेसिक प्रोपोर्शनलिटी थ्योरम मुझे कहीं भी यूज करना है तो फर्स्ट मुझे देना चाहिए कि टू साइड्स आर पैरेलल. ओके, PQ is parallel to AC. मेरे तरफ से आपको मैंने कह दिया कि PQ is parallel to AC. लेकिन इंटर आप क्या कह सकते हैं? What you can say? You can say BP by PA. अगर A parallel है, then you can say I will write here if PQ is parallel to AC, then what? BP divided by PA is equals to BQ divided by QC. BQ divided by QC. My dear children, here no parts will be equal. A इसे equal नहीं है, A उसे equal नहीं है. These two are not equal, but the sides are proportional. मतलब A दोनों को डिवाइड करने के बाद जो आंसर मिलेगा वही आंसर A दोनों को डिवाइड करने के बाद भी देना चाहिए. अगर A डिवाइड करने के बाद 3/2 आता है, A भी डिवाइड करने के बाद 3/2 ही आना चाहिए. Come on, take this. PQR. Yeah man. अब मैं क्या दे रहा हूँ? If Yemen is parallel to QR, अगर मैं आपको देता हूँ कि अगर ये दोनों आपस में पैरेलल है तो आप क्या कह सकते हैं? What you can say? You can say then can I say PM and PN are equal? No. Can I say PM and MQ are equal? No. Can I say MQ and NR are equal? No. I can say only this much. PM divided by MQ is equals to PN divided by NR. This is what Thale's theorem says. Come on, let's go for one more figure. Let me call P, Q, R, S, T. I'm giving you if ST is parallel to QR. ST is parallel to QR. अगर A दोनों मैंने आपको पहले बता दिया है, कोई भी आपको पैरेलल लाइन किसी को भी एक साइड को ड्रॉ करना है, चाहे इसको ड्रॉ करो, चाहे इसको ड्रॉ करो, चाहे इसको ड्रॉ करो, कोई फर्क नहीं पड़ता. एक साइड के लिए आपको पैरेलल ड्रॉ करना है. ओके, पैरेलल ड्रॉ कर दिया. अगर ये दोनों आपस में पैरेलल है, ये दोनों अगर आपस में पैरेलल है तो आप क्या लिख सकते हैं? PS by SQ is equals to PT by TR. कई बच्चे ऐसा बोल सकते हैं, सर क्या ये जरूरी है? क्या मैं यहां से स्टार्ट नहीं कर सकता हूं? Why not? Definitely you can start. You can write QS, then QS divided by SP. QS divided by SP is equals to, लेकिन अब जब आप यहां से स्टार्ट करोगे फिर ऐसा बच जाओ. अगर यहां से स्टार्ट करोगे तो आपको यहां से आना पड़ेगा RT divided by PT. RT divided by PT. This is what Thale's theorem says. Look at this. Okay, this is the Thale's theorem. You can apply for anything. But only condition is it should give you one triangle का कोई एक साइड के लिए मैंने पैरेलल देना पड़ेगा. बस then you can say. Here also you can say QM by MP is equals to RM by NP or PN. यहाँ मैं लिख सकता हूँ AP divided by PB is equals to CQ divided by QB. This is all about your very important Thale's theorem. Okay, students? We will stop our discussion here. Practice well, understand it well. After seeing this, try to solve it once, write it once without seeing, so that while we are solving the problem, you can solve the problems very easy. If you understand this Thale's theorem well. Okay, students? We'll stop here. Bye. Take care.